In this video, I'm going to look at application architectures. Application systems are designed to meet an organizational need. As businesses have much in common, the application systems also tend to have a common architecture that reflects the application requirements. A generic application architecture is an architecture for a type of software system that may be configured and adapted to create a system that meets specific requirements. So here we're going to look at which kinds of software patterns are useful in specific domain architectures. You can use application architectures as a starting point for architectural design, as a design checklist, a way of organizing the work of the development team, as a means of assessing components for reuse, as a vocabulary for talking about application types. So here are some examples that we can talk about. You have data processing applications, you have transaction processing applications, event processing systems, and language processing systems. These are all examples of application types. There are others out there. However, we're going to focus on transaction processing systems. You have examples of that, such as e-commerce systems. You have like reservation systems for like a hotel. You have language processing systems like compilers and command interpreters. This is not just human language processing systems like language translators. So transaction processing systems, they process user requests for information from a database or requests to update the database. From a user perspective, a transaction is any coherent sequence of operations that satisfies a goal. So find all the flights from London to Paris. Users can make asynchronous requests for service, which are then processed by a translation manager. So here's an idea of the structure of transaction processing applications. You should have the input-output processing, some kind of application logic, the transaction manager, which in turn talks to a database. So here's an example of how you can apply that for, say, an ATM. So the input coming from the ATM, you could have the customer account ID. You validate the card, you select what service you want, that's where you deposit or you're withdrawing or whatever. Then you have a process that goes through, which is you're querying the account, you're updating the account, and then you output back to the ATM. You have to print the detail, you have to return the card, you have to dispense the cash, things like that. So you also have things like information systems architecture, so you can organize that as, say, layered architecture, for example. So these are transaction-based systems, as interaction with these systems generally involves database transactions. So layers include, say, user interface, user communications, information retrieval, system database. And here's an example of the layered information system architecture, where at the top you have a user interface, then below that the communications and authentication authorization. Then you could get on to information retrieval and modification, and finally you have a transaction management and a database. So for the mental health facility patient management system, here's an example of a layered architecture that we can use there. We can have the web browser on top, then logging information, role checking, and the layer below again with security management. And as you go down, you get more you notice you have more security critical things as you move down the layers. Now you also have the web-based information systems. You can implement these with web browsers, such as e-commerce systems. These systems are often implemented as multi-tier client-server architectures, where the database servers move information to and from the database and handles transaction management. Okay, so finally getting on to language processing systems now. We can accept natural or artificial language as input and generate some other representation of that language. It may include an interpreter to act on the instructions in the language that is being processed. and is used in situations where the easiest way to solve a problem is to describe an algorithm or describe the system data. So here's an example using box and line diagram. Uh, so you have the source language instruction that's going to come in. You're going to first have a translator type application where we're going to check the syntax, check the semantics, and then generate. Then you're going to get the abstract instructions coming out of that. Then you're going to feed that into an interpreter, which is going to fetch and execute data and then come up with some set of results. So you can think about this as being, say, MATLAB if you want. So here's an example for a compiler. Compiler is composed of a lexical analyzer, so that takes the input language tokens and converts them into an internal form. What you mean by the tokens are like int I or double D or something like that. Then you have the symbol table, which holds the information about the names of the entities. So the function Fred will be held as the variable, the class names, the object names, using the text has been translated. You also have the syntax analyzer, which checks the syntax of the language being translated. And then you have syntax tree, which is an internal structure representing the program being compiled. You also have a semantic analyzer that uses information from the syntax tree and the symbol table to check the semantic correctness of the input language text. And you also have a code generator that walks the syntax tree and generates abstract machine code. So here's a pipe and filter compiler architecture. So you notice that you're transforming the human input through the lexical analysis, syntactic analysis, semantic analysis, and code generation, and you successively update the symbol tree and the syntax tree. So that's pipe and filter kind of combined a little bit with a central repository, where the symbol table and syntax tree kind of acts as the central repository in a sense. Here is a more repository architecture type look at it. So as you notice, all of the different types of processes are around the repository in essence. So the key points I want to take away from this one is that the models of the application system architectures, that those help us understand and compare the applications, and they validate the application system designs and assess large-scale components for reuse. Transaction processing systems are interactive systems that allow information in a database to be remotely accessed and modified by a number of users. Language processing systems are used to translate text from one language into another and to carry out the instructions specified in the input language. They include a translator and an abstract machine that executes to generate language. And that brings me to the end of this set of slides. Okay.